students, so this is problem number 2, and it's a situation where things look like they should work out to give the same answer for A and B, but it actually turns out they're not quite the same as far as numbers go. So let's just be clear. In this situation, in situation A, we're going to have a normal on B due to A equal to 20 newtons. And in the situation to the right, we're going to have, we're going to have a normal on B due to A equal to 10 newtons. And of course, by Newton's third law, this automatically means that this is equal to NAB here and NAB here. By Newton's third law, we're only interested in magnitudes. So our goal is to figure out what is the acceleration and what is FA, the applied force. We are also told that the combined mass is known to be 12 kilograms. So we also know that MA plus MB is 12. So I'll actually write that here. In both cases, MA plus MB equals 12 kilograms. What I'm going to do is, I'm not going to try to figure out the problem through some amazing new physics that I'm hiding from you. I'm going to do exactly the physics that we've been doing in class. So to start, let's do a free body diagram of block A. I've got the normal on A due to the floor, the weight of A due to the earth. I've got the force on A, and then I have the normal on A due to B, which we know is 20 newtons. We'll worry about that in a second. And then for block B, we have, this is block A, this is block B. We have the normal on B due to the floor, the weight of B due to the floor, and the force that actually accelerates block B is the normal on B due to A. So now we can set up some equations. One small thing, since we do not have friction, I am not going to worry about the vertical components because I only need vertical components when I'm worried about normal forces. So, and normal forces come into play when I have friction. And this is a frictionless surface. So I have FA minus NAB equals the mass of A times its acceleration. And then horizontally for the block B, I have the normal on B due to A equals MB times the acceleration. Now I'm going to have a similar set of free body diagrams in the second case. But now this is block B here, weight of B due to the earth. And sorry, this is normal on B due to the floor. I have the force applied, and I have a normal on B due to A. And then on block A, I have the normal force on A due to the floor, the weight of A due to the earth, and I have a normal on A because B pushes it. So here I can actually write the applied force minus N on B due to A equals mass of B times its acceleration. I also know that N on A due to B equals the mass of B times A. Sorry, not the mass of B. Let me write that again. The mass of block A times its acceleration, because that's the block that's being pushed by the contact force or the normal force. Now, here is where there is a leap of intuition that you only get through experience. Check this out. I have this equation here, which I'll call 1, and this equation here, which I'll call 2. And what I can do is I can actually shove those two equations together, and look what they get me. They get me that NBA plus NAB, different values, equal MA plus MB times the acceleration. But here's the thing. I was told right here that MA plus MB is 12 kilograms. I'll actually call that equation 3. So from equation 3, and from the other givens in the problem, I know that I have 20 plus 10 equals 12 times A. So I can actually write this as 20 newtons plus the 12 newtons that I'm given is going to equal the, that's 10. 20 plus 10. I'm a little under the weather, sorry about that. Equals a total of 12 kilograms times the acceleration. So I'm going to get 30 is 12 times A. That's going to be 10 is 4A when I reduce the fraction. That's going to end up giving me 5 over 2, which is 2.5 meters per second squared as my acceleration. And then I can go back and actually get FA any way that I want. So I could actually, I'll call this equation 4. And so what I'll say is, using equation 4 says FA minus my 10 equals so let's see if there's something else we can do, because that's not going to completely work. So I know one other idea that I can do. I'm going to take equation 4 and 2 and combine them in the following way. So what I can say is FA minus MA times A equals MB times A. And I can say FA equals MA plus MB times A. FA is going to be 12 kilograms times 2.5, which ends up being 30 newtons worth of force. So that is problem number 2.